In this video on research methods, what I would like to look at is going to be the research process. How exactly do we start the research process? What are the steps involved? And how are we going to go from the initial conception of this to doing the work to then writing it up? If we have to do a simple Google of what is the scientific method, the following slide is basically what we get, where we start at the top with an observation or a question, we move across to research topic area, we formulate a hypothesis, we test this with an experiment, we analyze the data, we report the conclusions, and then we come around back to the beginning where we have the observation or the questions from all of these steps going back to the research topic area. What I would like to propose here is that we expand this into a slightly more complicated diagram. So my diagram for the scientific method, we are again going to start at the top with the observation. What happens here is that we are going to see something interesting and we want to find out more. This something that we see might be something that has come from just our general understanding. It might come from a supervisor that has raised a question for us, and it may not be our own. It may be somebody else's completely. It might be an industrial partner who has raised something and they want to find out more. So we typically still start with an observation, and then we are going to move over to a question. And the questions are going to be something like what, how, when, why, all those type of questions. And typically they can be as many thoughts as possible that we have brainstormed down together. And we state here that there is no such thing as a silly idea. These are often grouped into ideas or common themes so that we don't have thousands of questions, but we can have some more complex questions in particular themes that can then get worked into our objectives and move around this circle as we've got it here. The research objectives are basically what do we want to achieve in our research? The questions that we had, the brainstorm that we had from before, the thousands and thousands of possible questions that we had, can be brought down to 3 to 5 key ideas. What is it that we actually want to work out or find out in this research? These could be individual chapters in your work. So for a PhD, it may be common or it is common to have one key idea or one research objective per chapter. But if these research objectives are fairly similar, it is also possible to have these in a single experiment where we are investigating several objectives in one step. After the research questions is the hypothesis. And the hypothesis is a proposed explanation made on the basis of a limited amount of evidence as the starting point for further investigation. At the bottom of the scientific method, the scientific process, we now look at experimentation. This is going to involve a lot of lab work for the work that I do, or computer modeling, or questionnaires and survey. This is the bulk of the work. So what are you actually doing? Let's go ahead and now go and fetch the information that we need so that we get all the raw data before we can analyze and find conclusions from what we are asking. From all those numbers that we obtained in the experimentation stage of this, we now want to look at the data analysis step. Are there any trends that should be seen, that can be seen? From the experimentation, are we going to be putting the data into a graph, a line graph, a bar chart, a pie graph? Are we drawing pictures, or are we just looking at the numbers themselves? Is there any trend that we need to be looking at, like an integral? Do we need to worry about error analysis or anything else like that in our study? So from all of this, we now want to have some sort of discussion. We've got a slope on a line, we've got a graph at least, we've got an integral. What exactly did that mean? What was exciting in the results? Was it what we expected based on the hypothesis? Have we actually met the objectives? Did we answer the questions that we set out in the beginning? Can we discuss any shortcomings or anything that we need to go back and relook at in our next round of experimentations? What exactly did we find out in our study? Have we done what we set out to do? Conclusions now summarize what was found. Through all of these different steps that we've got here, have we met what we've set out to achieve, and what was the actual number that we have gotten? This step isn't to say, yes, we did what we set out to achieve, but it's a step here that's going to say, this is exactly what was found. From that conclusion, we now change the top box into recommendations. So what new experiments could lead on from what we've just found out in this work? Are there any things that we found out in the experimentation that we realize now there were actually questions we should have asked at the beginning, which we didn't? Same thing, maybe there were objectives that we should have actually looked at, and we should now set a second set of experiments up. But given the time constraints, maybe that's a new degree all in its own. So now that top box is observation recommendations, and we can go around in this structure in a second way. But what I find on this diagram is that it is fairly linear, or it's not fairly linear, it's very linear in that it just goes in one direction around in circles. But what I find is that you can't always go in this direction, and sometimes when you've got to one point, you need to jump to another point and go from one section to the next. We should be looking backwards and forwards. From the experimentation, we might find that in our study, we wanted to know what is the effect of temperature on our system. So one of the questions might have been, what is the effect of temperature between 20 degrees Celsius and 40 degrees Celsius? In our experimentation, data analysis, and discussion, we might find that it had absolutely no impact at all. But we realized that the temperature should be taken up to 100 degrees Celsius for whatever reason. So we can now go back and change that question possibly and say, what is the effect of temperature up to a maximum of 120 degrees Celsius instead of our previous lower temperatures? And if we've gone back to the questions, we might want to change our research objectives and maybe even our hypothesis. So even though this has been drawn as a linear left to right, clockwise direction, please don't think of it that way, and you can jump from one point to another as you feel fit, depending on your research project. Now, even though I have just said that that circular, linear, clockwise pattern is jumbled up and we can jump from one step to the next, the problem with this is that we are going to be writing a document that is going to end up being a journal article or a thesis or a book or of some sort like that, that has a very linear pattern. And typically, the linear pattern is going to follow a pattern called the IMRAD pattern, which is an introduction, method, results, and discussion. So you're going to have to write an introduction, you're going to have to go to the next step, the third step, the fourth step in discussion, and there's not going to be much room to go backwards and forwards. There are some clever ways of doing that if you split up results and discussion into several results and discussion, but please remember that when you write it up, you're going to have to get around this. This IMRAD method, though, is presented here in the 4 letters for the name, I, M, R, and D, but in reality, we can also expand that to include an introduction, literature review, method, results, discussion, conclusions, and recommendations in a very similar way to what we did in our circular diagram from before.